Hello and welcome. My name is Kim and today I want to show you something that could change the way you think about inspecting steel plate structure. If you have ever needed to find hidden corrosion, pitting, or small cracks inside the steel plate without removing any coating and without moving heavy equipment, then this demonstration is for you. We are going to use a technology called guide wave plate inspection powered by MsS, Magnetostrictive Sensor technology. The software that runs the whole process is called GWP software, and it handles everything from data collection to generating your inspection report. In the next few minutes, I'll walk you through the test plate we'll be scanning and its known defects, how the hardware is connected, how to set up the software before a scan, the live scanning process itself, and finally, how to review the result and produce a PDF report. Let's begin. Before we scan, let me introduce the test plate. This is a steel plate that is a 1/4 inch thick, 14.5 inch wide, and 24 inches long, roughly the size of the large cutting board. We intentionally created 4 small defects in this plate, plus we bonded a 2 inch wide iron cobalt strip on the surface. You can see the defects marked here with the white circles on this top side of the plate. There is one defect near the bottom center. It is made up of 3 small holes, each 1/16 inch in diameter, drilled to half the wall thickness. Now, let's look at the bottom side of the plate, where the other 3 defects are located. The first defect is a single hole, 1/8 inch diameter at half wall depth. The second defect is 2 holes side by side, also 1/8 inch diameter each, at half wall depth. The third defect is the most complex, a large cluster made of 5 holes over 1/8 inch diameter and 6 holes at 1/16 inch diameter, all at half wall depth. The question is, can the GWP system find all 4 defects in a single scan? Let's find out. Now, let's set up the hardware. One you can see here is the MsS sector probe. I'm connecting a 128 kHz center frequency MsS adapter to ribbon cable. Here is the full setup for this demonstration. On one side, you have the MsSR V5 signal generation and acquisition instrument. On the other side is a standard laptop running the GWP software. When you open the GWP software, this is the first screen you will see. From here, you have access to all 3 phases of an inspection workflow: data acquisition, data analysis, and report generation. Everything is in one application. Before any scans, we check the instrument parameters. This is the instrument setting panel. While watching the live signal, you can fine-tune parameters such as gain here. This screen shows the signal amplitude in the real time as the probe moves. A smooth, steady motion is all that is required. And here is what the software displays during the scan. Each feature in this plot corresponds to something the guide waves encountered inside the plate, including the ends of the plate and any defect in between. Here's something that really shows the power of this technology. On one side, you have the GWP signal plot. On the other side is an actual plate. Notice how the signal features line up directly with the non-defect positions on the plate. Each peak or change in the signal corresponds to a physical feature, either a defect or the edge of the plate. This direct correlation gives the inspector high confidence in the result. Here I want to show you an important quality check. We scanned the plate in both the forward and backward directions with a small time interval between each pass. The 2 scans are displayed together here. You can see They match extremely well. The repeated signal pattern in the center of the plot confirms these are real defect indications, not random noise or instrument artifacts. This repeatability is a key sign of the reliable inspection result. One of the most practical questions from the new users is, does my scan speed matter? The answer, as you can see here, is not significantly. These two scans were done at a noticeably different speed, but look at the result. They match very well and both correctly identify all 4 defects in the plate. This means your operator do not need to maintain a precise fixed scan speed. A smooth natural motion is all that is needed. Once the scan is complete, we move to review and report screen. A software organizes all the scan information so you can locate, measure, and document any indications before creating the final report. Now, I'll set the scan range to focus on the area of interest. Here I have entered a range of 2 to 12.5 inches along the plate. With that set, look at the result. All 4 defects are clearly visible in the plot. A couple of the features worth pointing out. The 2 vertical red lines at about minus 0.45 feet and 1.55 feet mark the physical ends of the plate. The wide signal near the center between minus 0.25 and 0.25 feet is the initial pulse. This is always present and is not a defect. Everything else in the plot is a real indication from the inside the plate. When your analysis is complete, generating a report is just one click. The software creates a formatted PDF containing your scan results, ready to share with your client or include in your inspection records. The GWP software also includes advanced visualization tools. The 3D and data plot menu give you 2 options. The first is the Mesh 3D view, which you can see here. It shows you the full scan data as a 3-dimensional surface, a great way to visually communicate the findings to a client who may not be familiar with the traditional waveform plot. The second visualization option is the RF spectrogram plot. This view lets you look at the individual indication in detail. You can examine the RF signal, the video signal, and the spectrogram all at once for any point of interest. In this example, the indication is located at 5.1 inches from the bottom edge of the plate, marked here by the dotted red line on the 3D image. This level of the detail is useful when you want to characterize a defect more precisely and verify a questionable indication before writing the report. For each indication you want to document, you can click the Signal PDF button to generate a dedicated PDF page showing the signal plots for that indication. Here is an example. 2 indications located at 9.4 inches from the bottom plate edge, exported as a clean, ready to attach PDF. This makes it easy to include detailed signal evidence in your inspection report. This brings us to the end of this demonstration. To quickly summarize what we covered today, we introduced the MsS sector probe and test plate with 4 known defects. We worked through the hardware connection and the software setup. We performed the live scan and watched the data appear in real time. We verified the result using direct comparison, repeatability testing, and speed variation testing. And we showed how easy it is to generate dedicated PDF reports. If you are interested in learning more about the GWP technology or discussing how it could work for your specific inspection needs, please visit our website or contact us directly. Thank you for watching, and we hope to hear from you soon.